Hi, so let's do a couple more examples. I promise I won't make a mistake this time. The next molecule we want to use is, not molecule, element that we want to do is magnesium. Magnesium has an electron configuration of 1s2, 2s2, 2p6, 3s2. So basically, we want to draw out the orbitals and draw out the electrons that are in those orbitals. And that's basically going to give us an orbital filling diagram. I like boxes. I don't like using the lines, but you feel free to use the lines if you'd like. And then we go and we fill as we see the electron configuration. 2 electrons in the 1s orbital, so 1 up, 1 down. 2 electrons in the 2s orbital, 1 up, 1 down. 6 electrons in the 2p orbital, but I'm going to fill it according to Hund's rule because it's just good practice to do it that way. And then 2 in the s orbital, in the 3s orbital. And that is our orbital filling diagram for magnesium. The next example I'm going to do is arsenic, or As. And that has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. Now, again, I'm going to draw out the boxes, and hopefully I have enough space to do this. But it's essentially the same thing that we've been doing. We're just taking that electron configuration and basically just drawing a picture of it. So, again, we have 2, 2, 6, 2, 2, 6, 2, 10. So all of our orbitals are filled up until this point. So we've basically abided by the Aufbau principle. I'm going to go fill all those in, and you'll notice that I'm filling them in according to Hund's rule, just for good practice. But you don't have to if you know that the orbital's filled. And then once we get to the 4p orbital, I know my drawing's not really drawn to scale, but I'm going to fill the first 3, or the only 3, and we have no more electrons to work with. So this is the orbital filling diagram for arsenic. The last thing I want to do just for fun is to show you what the orbitals actually look like. The shapes that they take, which I think are a little silly. Maybe I'll have you guys perform the dance of each orbital. When we come back to class. But I'm going to use this as the nucleus for all 4 types of orbitals, the 4-orbitals. And we have the s orbital, just looks like a ring around the nucleus. So when the electron's orbiting in the s orbitals, it's just going in a circle around the nucleus. For the p orbital, if there's an electron in the p orbital, it also has an s orbital, but the p orbital is kind of shaped like an infinity sign. If you're in the d orbital, remember, if you're in the d orbital, you have an s and a p orbital, but the d orbital kind of looks like a clover. of sorts. And the last one, the f orbital, kind of looks like a flower with 3 petals on one side, 3 petals on the other side, and then 1 small petal on top, 1 small petal on the bottom. These are how the electrons orbit the nucleus, or kind of the path that they take. And then if you're wondering, well, I'm still struggling with orbital filling diagrams, remember to follow the rules. And here's a quick checklist that you can keep with you. The first one is write out the electron configuration. This will help you tremendously. Second is add your boxes and lines for each orbital. And then follow the Aufbau principle. The Pauli exclusion principle. And Hund's rule. We're going to do a lot of practice on this in class. That's all I have for you.